Nothing. Okay, so review number 2 is where we're at. Remember, we changed that number to a 2. Review number 2. And we are on the back side, is the one we're going to do together. I'll just at least quickly show the front side. We did this together yesterday. I'm not going to say anything really about it because we did all the talking yesterday, but this is just in case anyone was absent and goes back and looks. I will do the explaining part on the back side. So we are here. What? Please stop picking at that.
I want to do the answer.
You want to give me the answers?
Right.
Okay. This here, let me read it, then I'll get the numbers from you. There are 100 players who want to participate in the tournament match. Among the 100 players, 60 players will play in the baseball match, and 40 players will play in the football match. And 24 players will play in both the baseball and football match. All right, I am ready for your numbers.
Okay, so
Tell me where you started.
I started with the baseball, and I got 36.
36 here?
Mm-hmm.
What was the first number you put down? Was it the 36 or was it the overlap?
Oh, well, yeah, I started with the overlap, which
Okay.
is 24.
Okay, so overlap is 24. And then you said this piece is what?
I put 36.
Can you tell me how you got 36?
I did,
It's right.
60 minus 24.
60 players play baseball, and if 24 play both, 60 minus 24 is 36, so 36 play only baseball. All right, keep going.
And then on the football side, I put 16 because you do 40 minus 24, which is 16.
Good job. 40 players play football. If 24 play both, you subtract, that means 16 play only football. Yes.
And then for the bottom part, I put the 24 because if you add all those numbers up, it equals a number.
It equals.
Less than 100.
Okay, so he's saying if you add all these up, it equals a number that's less than 100. Does anybody have what the total is? 76. And then you do 100 minus 76, and does that equal 24? All right. So, how many people play football only? So let's look at the data. What did you get? 16. Where is the 16 coming from?
The right side.
Football only, because there's how many that play football? 40, but 24 play both, and 16 play only football. How many people play neither baseball nor football?
24.
24. Now be careful with that 24. Is it the 24 from the middle or the 24 on the outside?
Outside.
Outside. So if you want to put a little arrow so you don't get confused later on where it came from. All right. What is the probability that one of the 100 players picked at random would have played either baseball or football? There's different ways of doing it. Yes.
So I added up all the totals in the middle, and then I put it as a fraction, which is 76 over 100, which then you reduce, and that gives you, I can't, I'm not ready.
Okay, that's good though. With the way he explained it, did everybody hear the way he explained it? He said you add all these numbers together, these three, 76 out of 100, and then reduce. Does anybody want me to show you another way, or are you guys all good with that way?
Yeah.
The other way is using the actual formula. We'll call this event A and this event B. You would do probability of A plus the probability of B minus the overlap. How many football players or baseball players are there? 36 plus 24 is what? 60 out of 100 plus how many football players are there? 40. And then you take away the overlap. What's the overlap? The 24. Why would you take that away? Because you counted it twice. You counted it when you counted the football players, you counted it, or baseball, you counted it with the football. So then you would do 100 or 60 plus 40, take away 24 equals, and I plugged it in wrong, 60 plus 40 minus 24 equals 76. And is that the same number that Caleb came out with? So do you have to do it this longer way? No, I just want to show you the formulas that we've been using still work. P of A or B, because that's what it says here, or is addition. P of A or B equals P of A plus P of B minus the overlap. I'll write that here. P of A or B equals probability of A plus probability of B minus the overlap, or as Caleb did, just add these numbers and divide by 100. Does anybody have it reduced? 19 over 25? Thank you very much. All right, 19 over 25. Questions? None? All right. Yes.
Maybe you already addressed this one. I'm really confused on how you got 24 for 10.
24 over 10?
For 10, not over 10.
Oh, how many people play neither baseball nor football? Okay, first off, you don't know where this 24 is coming from. Is that what you're saying?
Yeah.
Okay. Caleb explained it. Can anyone else explain where he got the 24? Yes.
You just add all the numbers up, and there's 100, and you have to do how much you ever add up, and you have to minus that by 100. 76 minus 100 is 24.
Good job. Okay, so you add all these up. 76 people played baseball and or football, but there were 100 people that played in the tournament. So 100 take away this total is 24, which means 24 played, but they did not play baseball or football. They played something else.
I thought that was most people.
These two numbers just happen to come out to be the same. That was a coincidence. This 24 is not coming from that 24.
So who's the other side?
Yeah, I was thinking about that too. Like right here, 25 plus 30 plus 10 is 65, and 80 minus 65 is 15. It wasn't the overlap. We found it the same way. We add them all up and subtract from the total, and it came out to be 15. It just so happened that when we add these up and subtract from the total, it came out to be the same number. Coincidence, not intentional. All right? I know I don't like that. I'm gonna have to change it for next year. Okay. What is the probability that one of the 100 players picked at random would have played both baseball and football? What is the "and" meaning here? One more time, a little louder. Overlap. All right, where do the two overlap? 24 over 100. And make note again that 24 this time is coming from the overlap, where this one was coming from the extra. All right, anybody have that one reduced?
6 over 25.
6 over 25. All right, before I go any further, those of you that did it on your own, how are you guys doing so far? Pretty good? Pretty easy. All right. Are the events playing baseball and playing football mutually exclusive? Justify your answer. Mutually exclusive means there is no overlap. Is there overlap?
Yeah.
So is it mutually exclusive? No, there is overlap. Now,
Would there be any of them that are actually mutually exclusive?
not on a picture like this. If they give you a picture and there's overlap, they're not mutually exclusive. All right, if the picture was like one that we've had in notes or homework before, where the diagrams have two circles or two ovals that do not overlap, which I cannot seem to find, then those would be mutually, here it is. Are these events mutually exclusive? No. Is this event mutually exclusive? Yes. Okay, so now I had a kid yesterday say here, well, these have to be mutually exclusive because you can't visit Buffalo and Rochester at the same time. That's not what it's saying. Can you visit those two places on the same trip?
Yes.
Yes. When you go to New York, you can visit two different cities. Same thing here. You're not playing baseball and football at the same time, but can you play the two events in the same tournament? Yes. All right. There is overlap. 24 people played both baseball and football. All right, we're good? Are the events playing baseball and playing football independent? Justify your answer mathematically using the test for independence. Now it's specific here. What test do I have to use? The test for, and if I don't show that work, or if you don't show that work on the test, will you get it wrong? Yes. So let's first review what the test is. It's P of A and B equals what? P of A, what? Times P of B. Is that a formula you guys already know? Yes. Do you now need to know that this is also the test for independence? Yes. All right. This, in other words, is saying the what? Starts with the no. This is the overlap. And we're going to see if the overlap equals the product of P of A times P of B individually. All right, so let's do the overlap piece first. P of A and B. What's the probability of A and B happening together? That's the overlap. What is it? 24 out of 100. And we had that earlier. What did it reduce to? 6 over 25. Now I'm going to do this piece here. P of A times P of B equals. All right, probability of A is all of A happening. What's the probability of A happening?
60.
60 out of?
100.
Which, what did that reduce to earlier? Did we do that one? We did not. What does it reduce to now? 6 over 10 reduces to 3/5. Okay, times probability of B. What's the probability that the person plays football?
40.
40 out of? 2/5. And what's 3 over 5 times 2 over 5? Remember, you multiply the numerators, you multiply the denominators. What does that equal?
6 over 10.
And did they come out to be equal or not equal?
Equal.
They are the same. So are these independent? Yes or no?
Yes.
Yes. Now look at the one we had yesterday. Really, I will put it back. Why was the one we had yesterday not independent?
Because they didn't equal each other.
They were not. This one was 3/8. This one's 11 over 32. Do you see that? They were not independent because P of A and B did not equal the product of P of A and P of B. For this one, yes, because P of A and B equals P of A times P of B. So I'm going to look for two things on your test. I'm going to look for this piece. This is the work that you need to show here. And then I'm going to look for your yes or no answer. Yes, it is. No, it's not. And why? If you forget either one, are you going to get docked points?
Yes.
You're going to get the most docking points if you forget this. This is like the meat of the problem. But you definitely will get some docking if you don't put yes or no.
So when it asks that specific question, it's specifically asking for the overlap for the first part?
Yes.
Okay.
And this is asking for them individually being multiplied.
Okay.
Okay, so her question was, when they asked this first piece is specifically saying the overlap. What? Is this specifically asking for the overlap? Yes. And this is specifically saying probability of A by itself times probability of B by itself. In this case, it came out to be the same. Where in the other one, it did not. Questions on this?
Pretty easy.
That's pretty easy.
Said by Kelly.